Hello students. Well, in today's session, we'll talk about redox reactions. I'll tell you what redox reactions are. But before starting with that, I would like you to remember or recall reactions which you have done in your 10th standard, and we call them displacement reaction. For example, if you put a zinc rod in copper sulfate solution, you will observe that zinc will displace copper. It will get converted to zinc sulfate and will displace copper. This is a displacement reaction and this is also a redox reaction. In this reaction, you will see that zinc is getting converted to ZnSO4. See, I give you one example. Say I'm talking about H2SO4. You know H2SO4 is an acid and it has a tendency of donating H positive ion. So once it will donate 2 H positive ion, it will get converted to SO4 2 negative. That is a sulfate ion. So SO4 is always 2 negative. If here SO4 is 2 negative, copper is 2 positive. Likewise here SO4 is 2 negative, Zn is 2 positive. So if you see here Zn is losing electrons and is getting converted to Zn2 positive. Whereas copper is gaining electrons and it's getting converted to Cu. This loss of electrons is known as oxidation. And this gain of electron is known as a reduction. If I cancel out sulfate ion from both the sides, the equation becomes Zn plus Cu2 positive will give me Zn2 positive plus Cu. So we'll see what oxidation is. If I talk about oxidation basically is loss of electrons resulting in increase in positive charge and decrease in negative charge. For example, I have M that is losing electron and is getting converted to M positive. That again is losing electron and is getting converted to M2 positive. So this is oxidation. Likewise, I have M negative that is losing electron getting converted to M. That is losing another electron and is getting converted to M positive. So this is oxidation. Oxidation is loss of electron that results in increase in positive charge or decrease in negative charge. Likewise, if I talk about reduction, reduction is a process of gaining electron. So reduction is gain of electrons that results in increase in negative charge or decrease in positive charge. So suppose I have M that will gain electron will get converted to M negative. M negative, if it will again gain electron, will get converted to M2 negative. So reduction results in increase in negative charge. Likewise, suppose I have M positive plus electron will give you M. So it will result in decrease in positive charge and increase in negative charge. Again, oxidation is loss of electrons that results in increase in positive charge and decrease in negative charge. Reduction is gain of electron that results in increase in negative charge or decrease in positive charge. So what this type of reaction is. In this reaction, you are saying oxidation or oxidation, that is loss of electron, and reduction also, that is gain of electron. Such reaction is a redox reaction. I'll give you one more example for that. Suppose I put a copper wire in AgNO3 solution. I will get CuNO3 plus Ag. So it will displace silver. If you have a look at the reactant side, see NO3 is always single negative. Nitrate ion is single negative. You can recall it by considering HNO3. In HNO3, H is positive, so NO3 is negative. NO3 is always single negative. If NO3 is negative, Ag is positive. Here NO3 is negative, so copper is positive. If I cancel out the like ion from both the sides, NO3 from both the sides, my equation becomes Cu plus Ag positive will give me Cu positive plus Ag. That means copper is losing electrons, so it is undergoing oxidation. Whereas silver is gaining electrons, so it is undergoing reduction. And this reaction is a redox reaction. So what is a redox reaction? Reaction in which oxidation and reduction takes place simultaneously. So reactions in which reduction and oxidation takes place simultaneously are known as redox reactions. Now before proceeding with the redox reaction, we'll first see what is an oxidation number. Oxidation number. Well, we can define oxidation number in two different ways. Oxidation number is the number of electrons gained or lost by an element to become stable. So what is oxidation number? Oxidation number is the number of electrons gained or lost by an element to become stable. For example, if I talk about sodium chloride, in sodium chloride it is Na positive and Cl negative. So sodium has become stable by losing one electron, so its oxidation number is +1. Whereas chlorine has become stable by gaining one electron, that's why its oxidation number is -1. So oxidation number is the number of electrons gained or lost by an element to become stable. You can have other examples also, like we talk about CaCl2. Here you know Ca is 2 positive, so the oxidation number of calcium is +2, and chlorine is -1. You got two chlorine over here, that's why it's -1 into 2 for both the chlorines. So oxidation number is the number of electron gained or lost by an element to become stable. We can also define it in another way. The other way is, it is the number of bonds formed by an element if in these bonds it loses electrons its oxidation number is positive, and if it gains electrons, its oxidation number is negative. I'll give you one example for that. Suppose I have permanganate ion, MnO4 single negative. It's like this. Here you will see that manganese is forming 7 bonds with oxygen. 2 bonds here with 1 oxygen, 2 bonds each with 3 oxygen atoms, and 1 with O negative. So it is forming 7 bonds. Since oxygen is more electronegative, oxygen will attract those electrons toward itself. So oxygen will become negative and manganese will acquire a positive charge. So here the oxidation number of oxygen is -2, -2, -2 and -1 from manganese. That's why the oxidation number of manganese is +7. So what is oxidation number? Other definition, it is the number of bonds formed by an element. In these bonds, if it is losing electrons, the oxidation number is positive. If it is gaining electrons, the oxidation number is negative. So this is what oxidation number is. Now we'll see how to calculate oxidation number. We'll see rules. Rules for calculating oxidation number. Well, before starting with the rules, I will give you one example for that. Suppose here I am taking the same ion, that is MnO4 single negative. I need to calculate the oxidation number of manganese. So the element whose oxidation number is to be calculated is assigned an oxidation number X, which I don't know, plus oxidation number of rest of the elements which are attached to this atom. Here in this case, I have 4 oxygen atoms, and oxygen in most of its compounds exhibits an oxidation number of -2. So it is X plus 4 into -2 is equal to the charge on the molecule. That is what? -1. So it is X plus 4 into -2 is equal to -1. Here X comes out to be +7. That's why the oxidation number of manganese is +7. So first rule is what? The element whose oxidation number is to be calculated is assigned an oxidation number X. The oxidation number of rest of the elements is added to X and equated to the charge on the molecule. The value of X thus calculated is the oxidation number of the element. So this is how you have to calculate oxidation number. Second rule is oxidation number of fluorine in all its compounds is always -1. Likewise, oxidation number of oxygen in most of its compounds is -2. In peroxide, it is -1. Peroxide is O2 2 negative. And in superoxides, it is -half. Superoxide is O2 single negative. So this is for oxygen. Next, oxidation number of hydrogen in its compounds with metals is -1, and in its compounds with non-metals is +1. So hydrogen is more electronegative than metal. That's why it can gain electrons from metal, and that's why its oxidation number in its compounds with metals is -1. Whereas in its compounds with non-metals, they are always more electronegative than hydrogen. So they withdraw electron from hydrogen, and the oxidation number of hydrogen is +1 in its compounds with non-metals. Next, the oxidation number of an element in its elemental state is 0. That is, see, oxygen in nature exists as O2. So whenever you have O2, the oxidation number is 0. O2, N2, F2, Cl2, S8, P4. So whenever an element is in its elemental state, it is in a state in which it exists in the nature, its oxidation number is always 0. Sixth is the oxidation number of a monoatomic ion is always equal to the charge of the ion. Is always equal to the charge of the ion. For example, I have Na positive, so its oxidation number is +1. I have Ca2 positive, its oxidation number is +2. I have Al3 positive, its oxidation number is +3. Cl negative, the oxidation number is -1. O2 negative, the oxidation number is -2. So in monoatomic ion, the oxidation number is always equal to the charge on the ion. Next, the next rule is, in a compound formed between a metal and a non-metal, metal always shows positive oxidation state and non-metal shows negative oxidation state. Oxidation state and oxidation number They are all the way same. And the last rule is, in a compound formed between two non-metals, the more electronegative acquires negative oxidation number, and the less electronegative acquires positive oxidation number. So this is how you can calculate oxidation number. Although these rules, they look to be means you'll get a perception that there are so many rules for calculating oxidation number, but they are very easy rules. If you practice them, you calculate oxidation number of 2-3 molecules. You'll get acquainted with these rules. I'll give you some examples for that. Suppose I had to calculate oxidation number of sulfur. Then in K2Cr2O7 chromium. Then in say K2MnO4 manganese. Suppose these are the elements whose oxidation number I have to calculate. Let's see H2SO4. I told you that hydrogen's oxidation number is always +1 with non-metal. Sulfur is a non-metal. So here in this case, it is 2 into +1 plus sulfur, whose oxidation number is to be calculated, is X, plus 4 into -2, because the oxidation number of oxygen in most of its compounds is -2. So here in this case, I am getting 2 plus X minus 8 is equal to 0. That is, X is equal to 6. So in this compound, the oxidation number of sulfur is 6. Likewise, here in this case, potassium belongs to first group, and all first group elements, they exhibit an oxidation number of +1. So here in this case, it is 2 into +1 plus 2 into X. Because here you have 2 chromium, and by default the oxidation number of one of the chromium we are considering as X, plus 7 into -2. That is 2 plus 2X minus 14 is equal to 0. That is 2 plus 2X is equal to 14, or X is equal to 6. So in this case, the oxidation number of chromium is +6. Likewise, in the next one, 2 into +1, because potassium is first group element and they exhibit an oxidation state of +1 only, plus X plus 4 into -2 is equal to 0. That is 2 plus X minus 8 is equal to 0. 2 plus X is equal to +8. Then X is equal to 6. So in this case, K2MnO4, you are getting an oxidation state of +6. This is how you can calculate oxidation number. Now, after oxidation number, after learning how to calculate oxidation number, we'll move on to the next part, that is balancing of a redox reaction. As far balancing of a redox reaction is concerned, it is not so easy as you have done in 10th standard. In 10th standard, you are basically sticking to the law of conservation of matter. That means the number of atoms of any element on the reactant side should be equal to the number of atoms on the product side. Here in this case, you will not only balance the number of atoms, but along with that, you will also balance the charges on both the sides You'll also balance electrons on both the sides. So we have got a different set of rules for that. Balancing of redox reaction I will teach you in the next session, and we'll be balancing some chemical reactions in that. Meanwhile, I want you people to revise these set of rules for calculating oxidation number and do the questions which are given in the exercise of your textbook of this chapter, that is redox. Calculate oxidation number of elements. So in the next session, we'll be doing balancing of redox reaction, and we have got two different methods of balancing the redox reaction. That is the partial equation or oxidation number method and the ion electron method. So I'll be doing those two. That's all for today. Thanks for joining, and please do subscribe this channel. Thank you very much.